Welcome to Ask and Learn.
All right, in this problem, we're going to equate the energy at point 1 to the energy at point 2 because energy is conserved. So this means that kinetic energy at 1, which is 1/2 m times velocity at 1 squared, plus potential energy at point 1, mass times gravitational acceleration times height from ground level at point 1 is equal to the kinetic energy at point 2, with v2 being the second, or being the velocity at point 2. No potential energy, so that term isn't present, and energy due to friction, so let's call that E sub r. And so this is actually equal to force of friction times the distance traveled, and the distance traveled is given to us. We're going to work through it. So basically, you can divide both sides by m to get 1/2 v1 squared plus gy1 is equal to 1/2 v2 squared plus f, force of friction times distance over mass, right? So making v2 the subject, you have v2 equals square root of v1 squared. So we multiply, but before this, we multiply both sides by 2. We get v1 squared plus 2gy1 minus, this thing is pulled to the left-hand side, minus f of r, or 2 times force of friction times d over mass. Okay? And so now we can, and also remember that force of friction times d is actually, the force of friction is actually 0.23 times the weight. So that's 0.23 times mass. So force of friction times d, FFR, pardon my terrible writing there, force of friction times d is 0.23 times mg times d, therefore, okay? So v2 turns out to be v1 squared plus 2gy1 minus 2 times 0.23 is 0.46, so 0.46 times g times d, because the mass in the denominator cancels with the mass in the numerator. Okay, and finally, we can plug in values. v2 is square root of v1 squared, so that's 1.7 meters per second squared, plus 2 times 9.8 meters per second times height at 1, that's 32 meters. Okay, minus 0.46 times 9.8 meters per second, again, times 45 meters as the distance traveled as we're given. And so this gives us 20.7 meters per second for velocity at point 2.